So we're going to talk about something. We're going to go back to limits. Aren't we excited about going back to limits? Doesn't that sound like fun? Weren't limits a lot of fun at the beginning of the year? Actually, it was more like September, right? Because we did trig at the beginning of the year. All right, so it was easier. Okay, Marilyn, you're going to like today then, because today is way easy. We get to put some derivatives with the limits. Okay, so we're going to put them together. Okay. All right, so we tend to like Hopital over traditional limits. I don't understand, but we do for some reason. All right, don't leave, Marilyn. Don't leave, okay? All right, it's not too bad. It really isn't, okay? If you understand your derivative rules, your basic derivative rules, and you understand limits, this is kind of putting the two things together, okay? So, we had things like our pictured there in those first little examples. That's what we started the study of calculus with, okay? All we did was we plugged the number in. How great was that? That's like calculus. This is like the easiest class ever because all I got to do is plug in numbers, right? So let's look and see what happens when I plug in numbers to the ones that are in the box there, okay? So I'm going to blow it up just a little bit here. So if I'm going to plug in this 2, that means I would end up with 2 minus 2, which is 0, okay? And then if I'm going to plug the 2 into the denominator there, 2 squared is 4, and 4 minus 4 is 0. That is not something that we want to see, okay? It's something that we call an indeterminate form. I did not set my timer. I'm going to set my timer while you're writing that, while you're finishing that little spot up there. Okay, 17 minutes. All right, I'm going to plug infinity into this one. Well, infinity is going to make this numerator gigantic no matter what. It's going to make it look like infinity, right? And same thing with the denominator. When I plug infinity into that mass, it's still going to be infinity no matter what I do. That's another indeterminate form. These here are the indeterminate forms we typically see on the AB test, okay? And the BC test for that matter. These ones here are other ones. We will likely not see those, okay? They exist, but we are not going to see them because I'm not going to do problems out of the book. We're going to stick with kind of either an Otis or a Delta Math. Delta Math, hopefully they don't pop up, okay? It doesn't matter if it's positive or negative infinity. Any infinity over infinity, any sign is indeterminate, okay? So looking at these two limits, they gave us the pictures of these. Oh, by the way, you can look at it spelled a bazillion different ways. It's not La Hospital. Okay, it's La Hopital. It says down here that it's been spelled lots and lots of ways. They're both correct. Okay, so however you spell it, it's called La Hopital. Okay, it's pronounced that way. So if I'm looking at these functions here, okay, the picture for this one is this one here, and it says, hey, we're approaching 0. If I was to put 0 in here, I would get 0 over 0, which we know we really can't do, but look at it, 0. There's definitely a limit there, okay? This one here, it says I'm putting in infinity, but if I put infinity in there, I get infinity over infinity. And look, as we're going to infinity, it's definitely flattening out. There is a limit there. We have to have a way to get a limit. So we're going to use good old La Hopital's rule, okay? This is what La Hopital looked like, okay? He's credited with discovering this rule. So what La Hopital's rule is, I've got a function divided by a function, okay? Either both the top and the bottom equal 0, or both the top and the bottom equal infinity over infinity when I plug in, okay? So what he discovered is that if I take the limit of the original, it's the same as if I took the limit of the derivatives. And we're not talking quotient rule. We're talking take the derivative of the top and take the derivative of the bottom separately. Okay? All right. So you got to be careful not to mix this up with quotient rule. All right? So we're going to find each of the following limits. We are not allowed on the AP test to ever set something. We're not allowed to write it like this or like this, okay? If you write it like that, even though you are correct, they will not give you points, okay? So we're never going to write it like this again. I'm going to show you the proper way to write things, okay? So notation and writing it and expressing it properly is huge, okay? So let's make sure you get it expressed properly, okay? So we are going to start by trying to plug in, because you have to show that both the numerator and the denominator are 0 or infinity. So instead of just setting it equal and kind of plugging it in there, we're going to do them separately. So the limit as x approaches 2 of 3x squared minus 7x plus 2. Now I'm going to use direct substitution and plug in, just like we did first semester. So 3 squared minus 7 times 2 plus 2. And write small. I did not give you enough space. I need to edit these notes for next year for sure. All right, 3 squared is 4. 4 times 3 is 12. Negative 7 times 2 is negative 14. And then plus 2. I'm definitely seeing 12 plus 2 is 14 minus 14. I can rationalize that that is 0. And even if we're solving a limit that doesn't come out indeterminate, it's okay to do your limits like this. So if you wanted to substitute the numerator and denominator separately and then put them back together, you can do that. So you can do every limit this way, at least the setup, this beginning setup. So I'm going to do the limit now as x approaches 2 of the denominator, which is 2 minus 2, which is in fact 0. So I definitely have 0 over 0. I do not want to write 0 over 0 anywhere. Don't write it down. We just know that that's indeterminate. So I am going to invoke Hopital's rule. This is Mrs. Ballard's personal notation. I write a note to myself that I am doing Hopital's rule. It's not incorrect to write it down. The graders aren't going to read that. Okay? So I am now going to take the derivative of the numerator and the derivative of the denominator separately. So here's where you're going to help me in the chat because you should know how to do this. Okay, you ready? All right, so the derivative of the numerator, what is it? Looking at the numerator, make sure you're looking at the numerator, the top. Just the numerator. So I'm looking at this piece right here. What's that derivative? Okay, so remember I take the number and I bring it down to the front. So 3 times 2 would be 6x, and then the derivative of this would just be a negative 7. So we have to make sure you're doing the numerator. Now we're going to do the derivative of the denominator. So help me out. What's the derivative of this denominator here? That's where the 1 comes in. Good job. Okay. Now I am going to plug in. Okay, so I'm going to try plugging in direct substitution. I can do it separately, or I can plug in now. If you see zeros starting to come up, you need to switch and do it separately. Okay, so I'm plugging in my 2. So I'm going to go 6 times 2 minus 7, and that's going to give me 12 minus 7, which is 5. So that's my official final answer, is that 5. Okay, not too hard, right? We're not talking something that's super difficult. You got to know some basic derivative rules. You got to know to plug in some numbers to see if your numerator and denominator come out to be 0. Okay, let's try B. Write small, okay, because B came out to be a little bit uglier. I needed a little bit more space than what I gave. Not super ugly, okay, but it came out to be, it's got a rule in there we got to deal with. All right, so the first thing I'm going to do is plug into the numerator and denominator separately. Okay, so I'm going to start with the limit as x approaches negative 3 of x plus 3 and plug in, and I got my nice 0. Okay, they are all like this, Marilyn, except that we could apply other rules. So just keep watching. Okay, it wasn't too bad, was it? It's getting used to the hardest part is the notation right now, making sure you've got your notation correct. And I'm trying to be very explicit about that. Because we want to develop good habits now and not wait until we're 3 weeks out of the AP test, right? Okay, so I'm going to plug into the denominator separately. Okay, so I'm plugging in negative 3. I'm going to do a little bit of work in my head. I know negative 3 squared is 9. Minus 5 minus 2. 9 minus 5 is 4. Square root of 4 is 2 minus 2 is 0. So my numerator and my denominator both came out to be 0. Tell me in the chat, what rule am I going to use now? What rule am I supposed to use if my numerator and denominator come out to be both 0 or infinity? I like that we've already invoked the abbreviation. because Hopital is just too much to write out, okay? And again, this isn't something that's graded on the AP test, okay? If it was something where we're having to write out a sentence, right? You have like 15 minutes to write out that, to do the whole problem, right, on a free response. It's worth saving yourself thousands of dollars to not abbreviate, okay? It's thousands of college unit dollars, okay? So I read that on Facebook this morning. I'm like, that's a good idea. I gotta tell them that. So limit as x approaches -3. I've got to take the derivative of the numerator and derivative of the denominator. So derivative of the numerator, what am I going to do? What am I going to get? All right, excellent job. We're going to get a 1. Okay. Now, derivative of the denominator looks a little bit like I might have some extra work to do there. Is there another rule that I need to apply here? Do I need to apply a rule? If so, what rule do I need to apply? Marilyn's suggesting we do the chain rule. Jade is suggesting the same thing. So check it out. I kind of covered it up, huh? Let me uncover it. We have an inside function, so I am in fact going to use the chain rule. Okay, I'm going to do my work underneath here. I tried to write a little smaller so I had room for this work. So u equals x squared minus 5, which means that u prime is equal to 2x. So that's the inner function. The outer function, we'll go with green. I'm going to call it y equals, and I'm going to substitute the u in, minus 2. I'm going to rewrite that to the 1/2 power. So I get that y prime equals 1/2 u. I'm going to subtract 1, so it's going to make it -1/2. What's the derivative of any just constant? Can you guys tell me that in the chat? What's the derivative of any constant? Ah, nice job, 0, 0, 0. And then we multiply by the derivative of the inside. If I don't see you doing that on the test, I know you might not be using, you might be using something else to help you out, okay? It's very obvious when you are not doing the chain rule the way I taught it to you, okay? Not saying that it's wrong, but it's very obvious and it makes me suspicious about your work. So make sure you're working with honesty, okay? All right, I'm gonna rewrite that again a little bit because I got to substitute things back in. So I've got y prime equals, it looks like I'm keeping that orange 2x is going to go to the top. The 2 is going to be on the bottom. This is going to go on the bottom as u to the 1/2. And I'm writing a lot of steps so you can see every little tiny piece. And I'm going to make that a square root. Is there anything that I could do to simplify this just a little bit more? What do you guys see? Is there some way I could simplify that a little bit more as I'm plugging my u back in? Jaden just wrote 2. Is there something I need to do with the 2? Ah, yes, we're going to cancel out the 2's. There we go. Okay, so this is the derivative of the denominator. I'm going to plop it in here. Okay, I know we got an ugly complex fraction. We will deal with that here in a second. All right, let's plug in our numbers. So I'm plugging in the -3, and I'm plugging in the -3 into the denominator. -3 squared is 9. I got 1 over -3. Let's see, 9 minus 5 is 4. Square root of 4 is 2. And then in order to get rid of the complex fraction, which technically I don't have to on the AP test if it's open-ended, if it's free response, okay? I'm going to multiply by the reciprocal. So my final answer would be -2/3. Checking my timer. I've got 4 minutes left on my timer. Okay. We're going to see if I can do this next one without messing up my signs, okay? The signs were an issue on this next one. Okay, so the first thing we're going to do is we're going to plug in whatever number they give us separately to the numerator and the denominator. Okay, so let's start there. So the limit as x approaches -2 of x cubed plus x squared minus 8x minus 12. And it is super easy to mess up your signs, especially when there are screaming babies in the background, because that's what was happening during second period. You guys got lucky. My husband got done with his thing and I didn't have to deal with the babies. All right, they were definitely acting like they were 2 and 4 this morning. All right, -2 cubed is -8. -2 squared is +4. -8 times -2 is +16. And then we've got -12. All right, so let's see that. This makes 20, +20. That makes -20. I'm definitely seeing 0. Okay. All right. I'm going to do the denominator now. So limit as x approaches -2 of x cubed plus 8x squared plus 20x plus 16. We're going to plug in the -2. So -2 cubed plus 8 times -2 squared plus 20 times -2 plus 16. All right, -2 cubes, -8. -2 squared would be +4 times 8 would be +32. 20 times -2, -40, plus 16. All right, let's see what we got here. I see -48, +48. I'm getting 0. I did a lot better job on my signs this time. All right, so if I get 0 over 0, what rule do we need? Tell me in the chat again. Make sure we've got to understand this part of the lesson. That's it. Good old Hopital, right? Okay. So I am going to go to the right with my work because I do not have enough space to write there. Hopefully you wrote smaller or put a sticky note over it or something. I'm sorry that I did not give you enough space. So what happens when it's the first time through their notes, right? So I'm going to take this guy here and I'm going to kind of move him over. And I'm going to invoke my Hopital's rule. And I know that I have the limit still as x approaches -2. And let's see, derivative. I'm seeing 3x squared plus 2x minus 8 over 3x squared plus 16x plus 20. Okay. I'm going to do a little bit of side work here again. Okay, I'm going to try to do it, and probably do it in the center here. I'm going to try to plug in the -2. And I'm doing it over here because I know what's going to happen. And again, it doesn't hurt you to do the numerator and the denominator separately all the time if that's a habit you want to establish. Okay. So we've got 3 to, oh, not yet. I got to plug in, I got to write it out first. So 3x squared plus 2x minus 8. Then plug in the number. Plus 2 times -2 minus 8. All right, so let's see. -2 squared is 4 times 3 is 12. -2 times +2 is -4 minus 8. I'm definitely seeing 0 there. That could be a problem, right? I'm going to do the limit of the denominator. So we've got 3x squared plus 16x plus 20. So we've got 3 times -2 squared plus 16 times -2 plus 20. All right, so -2 squared is 4 times 3 is 12 again. 16 times -2 is -32 plus 20. Isn't 12 and 20 32? Uh-oh. I've got 0 over 0. Guess what I'm going to have to do? I'm going to have to do Hopital's rule again. Okay? Isn't this fun? So you can invoke Hopital over and over and over until it gets you a limit. Okay? Eventually, you will take enough derivatives that you will get a limit out of it. Okay, so I'm going to keep my limit notation until I've actually plugged that in officially. I'm going to take my derivative of my top and my derivative of my bottom. So that gives me 6x plus 2 in the top and 6x plus 16 in the bottom. I'm going to pause, make sure you're all caught up. All right, I'm going to plug in my -2. So 6 times -2 plus 2, I'm going to put an equal sign there, And then 6 times negative 2 plus 16. I could see that it wasn't going to be 0 this time, right? So it's okay if I write it this way. So I'm seeing negative 12 plus 2, negative 12 plus 16, negative 10 over, what, 4? So negative 5 halves if I was going to simplify all the way. I know it was quick, okay? I wanted us to have a little bit of a piece of making sure we kept moving on, but not go the entire period, okay? Because we didn't need 45 minutes of class today, all right? Because I know that some other teachers might do that, and I don't want it to be me that's stressing you out today, okay? Are there any questions? All right, so we didn't finish the lesson. Let me go in to really quickly showing you what I want you to do, okay? We are not going to do the test. I think I was off on my days. We'll do the test like Thursday, okay? Not like Tuesday, Wednesday. We're not ready yet. I still have to finish Hopital's rule. We still have to have some time for review, okay? So we will take the beginning of next week and do that. I might still add on, like, start moving you into 5-1. Okay, so I might move you into the next one. So hopefully if I can get some notes done over the lovely 3-day weekend we have this weekend, we will, so we'll move you, we might move you on. So I'm gonna kind of do double duty. We're gonna get ready for a test. We're not quite done with ready for Hopital homework yet, but I'm gonna give you a little bit of review stuff to start reviewing for the test. I didn't put an agenda up today. I'll put it up here in a few minutes. It was literally do the lesson and then do homework 8, okay? This is part of the test review. It's the from AP Classroom, okay? Notice it says skip problems 8 to 13. Remember I took out that chunk? We'll talk about what we're going to do with that chunk tomorrow, okay? I'll have that set up and ready to go for tomorrow. You might not be able to quite finish 16 to 18, but give them a try. We got to finish. We have enough Hopital knowledge. You might be able to do them. Okay, I still want this assignment in by Friday, okay, at 5, okay? You remember on an AP Classroom assignment, you don't have to get 70% to get full credit. You're not going to, because we're leaving out this huge chunk of problems, so it won't register as 70%. But do the best you can. These are AP level problems. You want to be practicing at that level all the time. And I'm probably going to pull something like 1 or 2 of these for the test next week. Okay. There will probably be an additional review in addition to this. Okay. So, but this is going to get us started. Okay. At the AP level. All right. I think we need a joke. Right? Andy's got a really good one today. Okay, so let's see. Let me see if I can get to it here. All right, let's rewind him. Did we get him to go? He's up there. He's a little dark today. We got to teach him about lighting.
So guys, I got a really funny joke for you. Oh, right. Don't do that. That'll be embarrassing. So, sorry about yesterday.
I'm going to answer that question in a second.
So, what do you get when you cross algebra and geometry with a banana? Wait a second. Oh, yeah. A slippery slope.
A slippery slope. I think we should change it to calculus. What do you call it when you cross calculus with a banana? A slippery slope, or derivative with a banana. A slippery slope. That would have made more sense, right? We could have made up our own joke. That was a really good one. I believe he got it off Alexa. It was originally geometry. Yeah, I think it does deserve applause. We could almost do the confetti, right? We could do the confetti. That one was so good, right? All right, there we go. Okay, so Ryan asked the question. The 2 notes we skipped are not going to be on the test. I'm not going to test you on them. I'm going to put that in as an extension assignment, and I'm going to give you a chance to get it done before the end of the triad for some extra credit. Okay. What it is it's something that, yes, it's going to be on the AP test. I know not everybody in the class is going for a 4 or a 5. Okay. So those of us that want to get in that 4 or 5 range or would like a little bit of extra credit, I want you guys should be trying it. Okay. You'll notice that there's QR codes you can scan. It's not me doing it. Okay. It's the guest teacher. All right. Because I borrowed his notes for it. So basically you're going to scan the QR code and watch the video. And then what I will do is I will also come up with a homework assignment so you can practice. Okay. I will happily help you with any of it. But if it was me, I would do like one a day, right? Scan one a day, do one example a day, and see if you can figure out related rates. It's really long, okay? So that's why I'm saying I'm going to give you to the end of the triad, okay? Don't throw them out. Keep them in there because you never know. You might want to go back and do it, all right? But definitely not on the test, okay? All right. If there are any other questions, comments, or concerns, I'm going to leave Google Meet on, but you guys are free to go today. We are done with our little asynchronous or synchronous time. You have asynchronous time. Take a few-minute break. Start working through the progress track. Okay? Have a great day. I will see you tomorrow. Bye, Jaden. Bye, Marilyn. You too, Fallon. Have a great day, kiddo.